Good morning, children. This is Javeria taking physical science for class 9th. We are into the fourth session of Unit 9, What is Inside Atom? In our previous session, we had seen how the electrons are distributed in various shells. In today's session, we'll be seeing few more concepts on distribution, atomic mass, mass number, and isotopes. Coming to the composition of atoms of the first 18 elements. The first element is hydrogen. Its symbol is H, atomic number is 1, and the number of protons and number of electrons is always same, because for in any atom the number of positive charges must always be equal to number of negative charges for the atom to be neutral. Okay, so you see this column and this column both are same. Number of protons or number of electrons is nothing but your atomic number. Okay, so this column, third column, and the fifth column will be the same. Okay, children. And how the electrons are distributed is there is only one electron, so it is occupying K shell. And since the valency is number of electrons in the outermost shell, you have the valency of hydrogen as 1. Then coming to helium, the symbol of helium is 2, He. Atomic number is 2. So number of protons and number of electrons is same. So it is again 2 in both the columns. And number of neutrons in helium is 2. So therefore, we know that the number of protons and number of neutrons will correspond to the nucleons present in an atom. Okay, and the number of protons and neutrons is equal to the atomic mass number. And just see, children, in hydrogen the number of neutrons is nil, 0. So hydrogen is the only element which doesn't have any neutrons. Coming to lithium, symbol of lithium is Li, number of, that is the atomic number is 3, number of protons is 3, and number of electrons is 3, and number of neutrons in lithium is 4. So 3 plus 4 will give you 7, which is the atomic mass number of lithium. Now here you see number of electrons in K shell is 2. Since its atomic number is 3, K shell can have not more than 2. You see in this column you have either 1 or 2. Only in hydrogen we have got one electron in K shell. Otherwise all the other elements have 2 electrons in the first shell. So lithium, the third electron goes into the L shell. Since one electron is there in the outermost shell, its valency is 1. But the valency of helium you see here is 0, because for helium and the other noble gases, the number of valency is 8 minus the group number, or 2 minus 2 in case of helium alone. So therefore its valency is 0. Now just come to carbon. Carbon symbol is C. Its atomic number is 6. Number of protons is 6 and number of electrons is 6. Whereas even number of neutrons is also 6. So 6 plus 6, that is protons plus neutrons, will give you the atomic mass number as 12 in case of carbon. And the electrons which are arranged are 2 electrons in the K shell and the remaining 4 out of 6 are in the L shell. So number of electrons in the outermost shell is 4. So your valency is also 4. Now coming to nitrogen, represented by the letter N, symbol is N, number of atomic number is 7, number of protons is 7, and number of electrons is 7, and even number of neutrons is also 7 in case of nitrogen. And when we come to the arrangement of electrons, 2 in the K shell, that is inner shell, and the remaining 5 in the next shell, that is second shell, L shell. Okay, children. Now since this is more than 4, valency will not be the number of electrons. You see from here 5, 6, 7, 8, whereas the valency is going on decreasing till 0, from 3 to 0. So the valency of these elements, that is the elements which have more than 4 electrons in their outermost shell, valency will be 8 minus the number of electrons. So 8 minus 5 is 3. Therefore, valency of nitrogen is 3. Let's see another element, that is oxygen. Symbol of oxygen is O. It is number of protons is 8, number of electrons is 8, so your atomic number is 8, and even the number of neutrons is 8 in oxygen. So 8 plus 8, which is 16. 16 is the atomic mass of oxygen. Coming to the arrangement of electrons, 2 in the K shell, remaining 6 in the L shell. Since we know valency is the number of electrons in the outermost shell, but here we see that it is greater than 4. So we will not consider that itself as the valency. We will subtract this from 8. So 8 minus 6 is 2. Therefore, the valency of oxygen is 2. Now let's go to chlorine. Chlorine symbol is Cl. Its atomic number is 17. Number of protons is 17. Number of electrons is 17. And arrangement, if we see, 2 in the inner shell, 8 in the next shell, that is your L shell. We know the capacity of L shell is only 8. So the next electron goes into the next shell. That is, we have got 7 more electrons in chlorine. So 7 more electrons go into the M shell. So number of electrons in the outermost shell is 7, but we can't take this as its valency, so we'll subtract this from 8. That is 8 minus 7, which is equal to 1. So 1 is the valency of chlorine. Now coming to argon, symbol is Ar. Atomic number is 18, number of protons is 18, number of electrons is 18, but the number of neutrons in argon is 22. Therefore, 18 plus 22 will give you 40 as the atomic mass number of argon. Coming to the distribution of electrons, 2 in the first shell, 8 in the next shell, that is L shell, and the remaining 8 in the M shell. And now we have got 8 electrons in the outermost shell. We can't take this as the valency. So 8 minus 8, which is equal to 0. So valency of argon is 0. So you see in this column, helium, neon and argon have valency as 0. So these three belong to the noble gas or inert gas family. Coming to atomic number and atomic mass number, the number of protons or electrons present in an atom is known as atomic number. It is represented by the letter Z. So the number of protons and neutrons present in the nucleus of an atom is known as atomic mass number. It is represented by the letter capital A. So atomic mass number equal to atomic number plus number of neutrons. We know atomic mass number represented by the letter A, number of protons by Z and number of neutrons by N. So A equal to Z plus N. If we write the symbol of fluorine, this is how we represent fluorine. Fluorine 919. We read this particular thing as F919, which is the 9 is the atomic number of fluorine and 19 is the mass number of fluorine. Coming to isotopes, the atoms of the same element which have the same number of protons but have different number of neutrons are called as isotopes. The chemical properties of isotopes are similar, but their physical properties are different. Deuterium and tritium are the isotopes of hydrogen. We know the atomic number of hydrogen is 1. So the normal hydrogen, which is also known as protium, it is H11. The number written at the bottom is the atomic number and the number written at the top is mass number. Just in the previous slide I had shown for fluorine. Similarly for hydrogen we are writing H11. Okay, so there is 1 electron in the outermost shell. Whereas when we are coming to deuterium and tritium, here also we have got 1 as the atomic number, but you see the mass number is different. That is, here the mass of hydrogen is 2, whereas here the mass number of hydrogen, that is number of neutrons, here we don't have any neutrons, that is why it is only 1. Here we have got 1 neutron, no doubt 1 proton is there, along with 1 proton 1 neutron is there, so 1 plus 1 it is 2. But in tritium we have got 2 neutrons, 1 proton and 2 neutron. So the atomic mass number of tritium is 3. Therefore, we write it as H13. So these three are the isotopes of hydrogen. Protium, deuterium, and tritium are the isotopes of hydrogen. Now, when we see the isotopes of carbon, again we have carbon C612, carbon C613, and carbon C614. These three are the isotopes of carbon. So atomic numbers you just see are all same, whereas your mass numbers are differing. Here you have got 12, here 13, and here 14. So number of neutrons present in C612 is 6, number of neutrons present in C613 is 7, and number of neutrons present in C614 is 8. You have protons, neutrons we are representing by pink spheres. So you have got 6 neutrons here, 7 neutrons here, and 8 neutrons here. Okay, children. So these are the isotopes of carbon. Now coming to applications of isotopes of carbon, isotopes are used for solving chemical and medical mysteries. They are commonly used in the laboratory to investigate the steps of a chemical reaction. The isotope of uranium, you know uranium is a radioactive element. It is used as a fuel in nuclear reactors. The isotope of iodine is used in the treatment of goiter, and the isotope of cobalt is used in the treatment of cancer. Coming to the assignment, what is the maximum number of electrons in M shell? Second question, define atomic number and atomic mass number. Third question, what are isotopes? And the fourth question, name the isotopes of hydrogen. Thank you.